Good morning to everyone, and once again welcome back to my channel Team Mechanical. Today I will be discuss about the duty cycle, arc on time, rest time. What are basically these points related to our welding? Okay, so let's go to the point of discussion. First one, before discuss about the duty cycle, first discuss about the arc on time. Arc on time in shortly you can write down as the AOT. Okay, arc on time. Basically what happened now during your welding, if you observe any welding operation, then you can easily feel that during your welding always the spark is not going on. Okay, spark is going on for a certain period, and then again welder pull up the electrode at a certain distance from the workpiece, and this times your arc is not going on. Basically the welding is not performing in that particular period. So this arc on time is that particular period. Okay, this one is that particular time, you can say, when the welding is going on. Okay, the welding is performing, or you can say performing, or arc is established between the electrode and workpiece. Okay, electrode and workpiece. So carefully try to understand. Your arc on time and welding time is different. Okay, if arc on time means your arc is established in between the electrode and workpiece and your welding is going on. Okay, suppose if I take this is my two workpiece. Okay, this one is my two workpiece, this one and this one. Okay, so here welding will be going on, and when this particular welding is going on, this time is your arc on time. Okay, now rest time is, suppose, listen, when the welding is going on, my electrode is at a certain distance from the workpiece and the arc is created in between the electrode and workpiece, so welding is going on. This is your arc on time. But for a certain period, if I created a distance between the electrode and workpiece more than the requirement, and this time your arc is not established in between the workpiece and electrode, so this time any welding is not performing. So this time is your basically rest time. Okay, so you can say rest time is the time when welding is not, when joining is not performing. Okay, or you can say your welding is not performing. Now this is arc on time. This total welding time can be written as a total welding time. You can write it as a arc on time plus rest time. Means when you are performing the welding, these times also this time your arc is on, so this is arc on time, and when arc is not on, so your welding is not performing, these times also you have to add here to get the total welding time. Okay, so it's rest time. So this concept is clear. Now come to the point, duty cycle. Okay, what is the duty cycle? Now duty cycle, you can write it as a ratio. Oh, it is a ratio. You can write it as duty cycle is the ratio of your arc on time by total welding time. Okay, total welding time. Okay, arc on time by total welding time. So duty cycle is the ratio of these two. During your total welding time, through which period your arc is on, this one is basically known as the arc on time. So this arc on time by total welding time is your duty cycle. Now this total welding time also you can write arc on time plus rest time. So just write it, arc on time plus rest time. Okay, so this is your duty cycle. So carefully understand what is the basic of this one. Duty cycle is nothing but your arc on time by arc on time plus rest time. The summation of these two is your total welding time. So up to now it's clear. Let's take an example which is basically come in your GATE exam in 1991. So I will be take these questions for your better understanding purpose. Okay. So before solving the questions, let's discuss about a very important topic is that your duty cycle, if it is represented by D and current square is always constant. Okay, this one is very important one, please note down it in your paper. Okay, so this multiplication of duty cycle and current square is constant, where D is your duty cycle and I is your current. Okay, so current. Now what is basically happened, your rated duty cycle and rated current is different, and your requirement or your desired duty cycle and desired current is different. So from this point of view you can write down your rated duty cycle into rated current square is your equal to the desired duty cycle and desired current square. Am I right? Okay, so this one is you have to basically remember. Just remember this one, the duty cycle and current square is constant. So this one here, this small suffix D represent. Okay, I am writing here all those things. Desired, this is desired duty cycle. Okay, this one is desired duty cycle, and this one is your rated duty cycle. Rated duty cycle. This one is your desired current. Okay, and this one is your rated current. Rated current. Okay, so let's carefully read the question. What they are basically said in this question, a resistance welder is rated at 50 kilovolt ampere. So this 50 kilovolt ampere, from the unit what you can say, this is your power. Okay, so this you can say power is given. Okay, so power is how much given, 50 kilovolt ampere. Okay, here I am writing given data. Okay, given data. So your power is given 50 kilovolt ampere at how much duty cycle, 50% duty cycle. Now you just say me, this duty cycle is your rated duty cycle or desired duty cycle. Our resistance welder is rated at this much kilovolt ampere at 50% duty cycle. So this duty cycle is nothing but your rated duty cycle. Okay, so you can write it here, rated duty cycle is 50%. Okay, then secondary voltage is always constant. This term is important. Secondary voltage is always constant at 25 volt. Now when you are performing the welding, obviously you know that in your transformer the secondary voltage is basically used. Okay, primary voltage is basically high, very high, at 220 voltage or something like that, and from there we are step down the voltage and using some around 70, 60 to 80, something like that. Okay, so here secondary voltage is always constant, 25 volt. So you can write down voltage is equal to 25 volt. If a job requires 1500 amperes current, now here if a job require means this one is your rated current. Am I right? Sorry, desired current, not a rated current, requirement or desired current. So this one is your desired current. ID is given 1500 ampere. Now determine the maximum welding time in a total cycle time of 30 seconds. Now here most of the time all the students are get confused that maximum welding time, don't be confused in between the arc on time and welding time. Basically here you can observe maximum welding time, nothing but your arc on time they are asked. Why I am saying that your maximum welding time is arc on time? Because if they are not ask you the total welding time, that means it's a arc on time. Okay, if in case of the maximum welding time, if they are ask you the total welding time, then your arc on time plus rest or rest time. But here they are asked maximum welding time, means you should not consider the rest time within this arc on time. Okay, now so and they are give us the total cycle time. Here total cycle time means they are basically give you the total welding time. Okay, so total cycle time they are provide you how much, 30 second. So this one is basically equal to your total welding time, total welding time. So basically you have to carefully observe what are the given data is present here. So let's solve the question. So power is nothing but your V into I, and this one is your 50 kilovolt ampere. If you want to convert it in volt ampere, so multiply by 10 cube. Am I right? So when so this voltage is given, so this rated current, this current is here nothing but your rated current. So we can find out the rated current as this one divided by voltage how much, 25 volt, and we will be get the answer as a how much, not 2000 ampere. Okay, 2000 ampere. So this one is your rated current. Now your rated current is there, rated duty cycle is there, and your desired current is there. So by using this equation we can find out our desired duty cycle. So let's find out desired duty cycle. How you can write down your rated duty cycle, rated current square by desired current square. Your rated duty cycle is 50%. Okay, now into rated current we are find out it 2000. So 2000 square by your desired duty current is 1500, they are given in your question. So this one, so from here if you calculate this, you will be get that 88.8 is your desired duty cycle, and this one is in percentage, because here we take the rated duty cycle as a percentage 50%. So here it is in percentage. The relation, the duty cycle is equal to your arc on time by total welding time. Okay, so this one your arc on time by total welding time. So here we have to find out the maximum welding time. Okay, we have to find out the maximum welding time, and in this question basically this maximum welding time is nothing but my arc on time. So this arc on time is equal to duty cycle into total welding time, and duty cycle is already we are find out that 88.8 in percentage, so let it convert. And then total welding time, for how much time we have to find out, now for 30 second we have to find out, so multiply by 30. Okay, so it's clear now. Arc on time if we try to find out, just take this total welding time by here, so you will be get arc on time is equal to 88.8. I am dividing it by 100 because it is present in percentage, then multiply by 30. So from here if you calculate it, you will be get the answer as a 26.67 second. Okay, so I think the concept is now clear to you.